All right. Pardon me, fella. All right, tonight's homework, W2.0d. Let me tell you how to do this. It may look a little tricky, but it's actually not. So notice up here, it says um, the relevant equations are the first five, actually primarily 3, 4, and 5 on the left side of PRT 6. So you need your reference table. Here's a little cropping of that reference table. And then notice, here's equations 1, 2, 3, 4, 5. Those are the five you have to worry about. Primarily, it's going to be 3, 4, and 5. Okay? Those we will use while doing this assignment. All right, let's clear this up. Now, let's go through this. So, Mr. Burbitt's Subaru accelerates from rest to a speed of 25 meters per second in 8.5 seconds. What is the magnitude of his acceleration? Sounds like a lot, but actually, if you break it down into what's actually being stated, it's pretty straightforward. I'll give you a heads up onto which givens. So which givens are required for this problem? So we're using what's called a guess format. Of course, guess there is just an acronym. The GU is the givens with units. The E is the equation. That's the unsubstituted or blank equation. And the SS is substitute and solve. If you take these 5 steps as you approach any word problem, you are highly likely to get it correct. If not, the likelihood goes down. This works all year, so a very important protocol to get used to. All right. Sometimes we informally call this our givens with units. All right. So back over here. Of the physical quantities here, you will notice, actually we'll make a list up top, which are actually part of equations 1 through 5. So again, 1, 2, 3, 4, 5. The givens you will see are V bar, you will see D, T, A, delta V, there's T again, there's VF, there's VI, and then there's A and T, and again D, VI, T, A and T, VF, VI, A and D. So there are seven total givens expressed in these 5 equations right here. So in order to do these problems, you need to know what are these 7 givens. Well, you know most of them already, and those you don't know are not that tricky. So those that you know already are as follows. You know average speed, you know distance or displacement, you know time. You don't really know what acceleration is, but you've seen it. Now these are adjustments to velocity. You should have a rough idea of this one, which is just your change in velocity or change in speed. The last 2 you see there, VI and VF, are listed over here in your reference table. Well, I think they are. Maybe they're not listed. Oh, well, if they're not, it doesn't matter. It's easy anyway. VI and VF, let's indicate what they are right now. I stands for initial or starting. So VI is what we call initial speed or velocity. And VF is your final speed or velocity. Now, initial just means how it starts. Final just means how it ends. And if you recall, these problems begin and end where we define. So let's get back to this question right here. Now, in bold are the givens. So it's kind of a giveaway, a givens giveaway. Here it is. Let's go to a nice light color. This one. All right. Mr. Burbett Subaru accelerates from rest. That is a given. To a speed of 25 meters per second. That's a given. In 8.5 seconds. That's a given. What is the magnitude of his acceleration? That's a given. So there are actually 4 givens presented here. Let's label them so we have an idea of what we're dealing with. And then all the other problems are the same way. From rest. Rest is defined. This word rest means V equals 0. Speed or velocity is 0. This also is a speed, 25 meters per second. So you know V equals 25. We'll worry about the units in a moment. We write them over here with our givens. We have 2 different V's. Generally, when that happens, that's not going to be okay. Our V's have to look like these up here, which is a VF, a VI, a V bar, a delta V, and then of course you get your DAT. Right now, these are just plain old V. This is not V bar right here. I just underline the word rest. So maybe let me remove that underline so this doesn't throw you off. How do you know this? This actually comes down to basic English. From rest to the speed of 25. From indicates that's how it started. So this V is in fact VI. To indicates that how it ends. So this V is in fact VF. So when you properly set up your givens here, your VI, or your starting speed, this one right here, is 0 meters per second. Yes, put your units with it, even a 0. To 25 meters per second, that's your ending or your final speed. That goes here, 25 meters per second. Time that's been provided to you is 8.5 s per second. If your 5s and s's look alike, which they kind of do on the board here, I would write SEC to make sure. And then finally, what is the acceleration? That is what we do not know. We will put that as a question mark. Hopefully you've seen from some of the graphs we've done, the unit that goes with acceleration is meter per second squared. Now, notice I have been very thorough. I have written my givens with units. So givens with units, there's a reason for that. You'll see in a moment. Now, the key here is we must find an equation that allows us to solve for acceleration. That's what this problem is about. So you must pick an equation that allows you to solve for acceleration. Now, among these here on the reference table, the choices that have acceleration are choice 2, 3, 4, and 5. It has to be one of those. Don't use V bar equals D over T. There is no A. That will not solve for acceleration. So which one will do it? Well, then you look at the supporting characters here. Which one of these equations casts these characters? VI, VF, and T. Well, there are actually two options. The most direct option is this one right here. That's this one right here. There's a VF, there's a VI, there's an A, there's a T. And so we want A, we have VI, VF, T. Our equation in this case would be VF equals VI plus AT. Now, since we are solving for acceleration, we might choose to rearrange this equation. I actually recommend this. You don't have to do this, but I recommend this. How would you do that? You would subtract VI from both sides. So you would have VF minus VI, and then that would equal A times T. You would divide both sides by time, and you would be left with A equals VF minus VI divided by T. Now, this is a very easy way to solve this problem. A equals VF 25. Now, watch this. This is a favor. This is a gift. If you make a nice complete set of givens with units, thorough, all of them plus their units, then the gift will be you do not need to include the units over here when you solve the problem. Now, leaving units in your solution is actually a good habit because you learn how to cancel units, etc. Check whether your answer makes sense. However, sometimes it becomes alphabet soup and confusing. If that's the case, just leave your units out of the equation, leave numbers only, and then put your units over here with your givens with units. That will be acceptable for full credit. So here I'll leave them out. 25 minus 0 was VI, meters per second, divided by 8.5 seconds. And then, of course, your final answer, A is going to be 25 over 8.5. And whatever it says in the answer key there, that's going to be correct. And what's it say? So, what's the answer, number 1?
Oh, I didn't do that.
Look at the key.
Oh, 2.9 meters per second.
Okay, 2.9. And you need to know the unit on the answer. That's why we write it over here with our givens. Acceleration is meter per second squared. If you were unsure what the unit would be, That's a good reason to put your units up here. Meter per second over second. And we've done that before. Meter per second over second, keep change flip. It's meter per second times 1 over second. It's meter per second squared. Okay? Now, in case you are interested,
one bus announcement.
one bus
All
announcement.
students that normally take middle high school bus 2 will have to go on bus 3. Again, bus
Heard that?
2 will go on bus 3.
Bus 2
Thank
go
you.
on bus 3. All right, anyway. You could have used equation 2, A equals delta V over T. I have not trained you in that equation yet. If you were thinking of using this equation, just beware delta V, which is the change in speed or velocity, delta V is explicitly defined as the final speed minus the initial, not just vaguely the difference between them. Vf minus Vi and Vi minus Vf are not the same thing. So for now, I recommend you choose equation 3 for this one. It directly fits exactly what we're doing, and it brings you exactly to the solution. That should be a nice, simple assignment to do. Just take your time picking the givens that go with the problem. I'll help you with the givens for question 2, and then you're on your own. Let me get this guy out of the way. Let's erase some of these extra marks. Okay, so let's look here at question 2. Now, once Mr. Burbot reaches 25 meters per second, he slams on the brakes and brings the car to rest over a distance of 14 meters. What is the magnitude and direction of his acceleration? Okay, well, what is the starting speed in this case? He is going 25 meters per second. So the initial speed is 25 meters per second.
236 to pick up your senior shirts right now.
He brings
Again,
the car
seniors,
to
make sure to
rest.
stop by Miss Steepo's
That
room.
means that's the ending. That's not how it
236 to pick up your
started.
senior shirts
That's
right
the
now.
ending. So the final speed is 0 meters per second. They provided a distance, 14 meters. And again, the question is acceleration. Put a question mark, meters per second. I do not recommend writing X for your unknown. X means change in spring length. Okay, next move. We must solve for acceleration. So you better pick an equation with acceleration. As it turns out, again, we have 4 choices. Here they are.
Miss McDevitt, please call the office, the attendant's office.
1, 2,
Miss
3,
McDevitt,
4,
please call the
5.
attendant's office.
And among those, one has a set of characters that matches this cast, VI, VF, and D. Let's go and look. This one has a T in it, so that's not it. This one has a T, so that's not it. But this one has VF, VI, A, and D. That's our friend. So our equation that will actually allow us to attack this problem is VF squared equals VI squared plus 2AD. Again, you are solving for acceleration, so I would strongly recommend you play the rearrange game. You don't have to. This is not required, but I recommend it. And if you did, you see it's pretty easy to do. You need to get the VI away. So VF squared, let's subtract VI squared from both sides, equals 2AD. You're going to divide both sides by 2D. You'll be left with the acceleration. And that allows you to finish this up. So this should be, once you get the givens on point, this is a pretty straightforward process.